So we explained the first part of this course, which is statistics, in terms of understanding what qualitative and quantitative data is. So question one basically wants to find out your understanding on you able to distinguish what quantitative and qualitative data is. So quickly, what type of data is the number of female professors in mathematics? What type of data is this? Anyone? Quickly. Yes, Faith? Can you hear me? Okay, so the number of female professors looks at quantitative data. It's looking at the frequency. So number of female, that is quantitative data, but discrete. Then the country of birth of a random selected graduate student. Basically, this is what? Qualitative. To be specific, that is nominal. Nominal is distinctive. You can't be born in two places. And the number of female, this is distinctive. Right? By whether one is either two, there's nothing in between, like 1.5. The favorite sport one can have, this is what?
Quantitative, qualitative.
Quantitative, and what specifically? Is it ordinal or nominal? The volume of gasoline remaining in your tank, that is what? Quantitative, continuous. Now, whether it's quantitative, continuous, just mention quantitative, quantitative. Don't overindulge. The brand owned by an university student is what? This is
Qualitative.
quantitative. All right. So that is the first part of it. We also went to look at how to calculate the mean, the variance, standard deviation. So this is a sample. So to find the mean, you sum up everything in here and divide by the number of elements we have. The variance, I gave you the formula. You find the summation of x squared minus summation of x, the power 2 over n, everything over n minus 1. So the answer that you get is the variance. When you square root it, it's called the standard deviation. For the measures of location, we established that you rearrange the information in order of ascending. Then half of n is your location, your position. If you find, for instance, these are 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 24. So half of n is what? Half of 24 is 12. So you get the 12th and the 13th number, you average them. So that is the median. The mode looks at the most frequent element in here, what is appearing the most. So if you're going to check closely, I don't know, we found 80 or 88, something like that, something that's appearing the most. The first and second quarter, and identifying the outlier. So we did this.
Things don't work out like that.
All right.
Huh?
So now we went to counting numbers. So this is to do with permutations and combinations. So if you're given combination and permutation, permutation is given by this formula, n factorial over n minus r. Okay, we're dealing with combination. Who remembers the formula? Okay, so these formulas are very important in understanding counting of numbers. So on your calculator, you'll see these functions. There's a permutation, there's a combination. So this combination can come out like that, right? So now I want to show you how to expand that. So using the formula that you can see there, if you're given a formula like 5 combination 3, basically this means that you are going to what? Compute it as follows: 5 minus 3 factorial and 3 factorial. So this will give you 5 factorial over the difference is what? 2. And the radical is 3 there. So what is the factorial? When you're dealing with the factorial, you're looking at the number that is multiplied backwards. So this is 4 times 3 times 2 times 1. When you multiply that, we're going to get what? 24. This is the factorial we're talking about. We are multiplying backwards. 3 factorial means what? We're multiplying 3 backwards, which is 3 times 2 times 1. You need to know how the factorials work. 0 factorial implies you're multiplying. So this one is a special one. So 0 factorial is 1. So how do we evaluate 5 combination 3? You can use a calculator or you can use this formula. So 5 factorial is simply 5 times what? 4 times. When I put a decimal, it means that I'm just multiplying. Then what is 2 factorial? 2 times 1, 3 factorial, 3 times 2 times 1. This is that. And here we're getting a what? Is that clear? So here we're going to get a 10. So let's try to find the combination of this one. Let's see. 5 combination 2. Six combination 2, what do we get? So the 6 factorial, then the difference 6 minus 2 is what? 4. Then we bring it back there, so 2 factorial. You need to understand the pattern here. This is very important. So if you're going to break down the 6 times what? 5 times what? 4 times what? 3 times what? 2 times 1. Then I would rather start with the bigger one to break it down. 4 times 3 times 2 times 1. Then this 2 is 2 times 1. So this will cancel. And this one here, 2 in there, 3. So 3 times 5, we're going to get a 15. So 6 combination 2, the answer is 15. Now what I'm trying to get to, for example, people say sometimes to understand, sometimes they'll say, show that n combination R, if you're going to compute that, is the same as n over n minus R. So using letters, what did I say? For instance, if you have A and B, how do we do the combination for this one? I said the top guy is our n, so it's A factorial over the difference between the two, A minus B factorial times what? The bottom guy
Mhm.
factorial.
B
So let's do
factorial.
this, let's see if they're the same. Let's expand this part here to be n factorial over what? N minus r factorial, right? Times what? R factorial. Yeah.
Factorial.
Let's do the same on the right hand side. Okay, let's do the same on the other side to see whether we're going to get the same. So this will be n factorial, that is our a. Then a minus this, like n minus r. I don't know how people get confused on this part. So that's why I'm using these brackets here. N minus what? N minus r factorial. These guys are b. Then the b now alone is n minus r. N minus r. So let's see whether these two are likened. So our n factorial remains on top. So in this case, we're going to have n minus n, then minus and minus with what? Plus. This is factorial. And this side, we can simplify it and just leave it as it is. So this means that n minus n is 0. So this side, we're going to remain with simply our r factorial. So in this case, we're going to have r factorial and n minus r factorial. Are they the same with this part? Yes. So this is the same as that, hence shown. So this carries about 6 marks. You need to know how to do the manipulations.
Mr. Collins.
Yes, sir.
Yeah, I know. I'm trying to. How do questions come on this one? Can you maybe show us just one question so that I can? I found you calculating, and it seemed
It
to
will
be
just
that.
come, they show that
Uh-huh.
n over r is equal to n minus n. So that
Okay,
this is that. That's how the question will come. We're just proving.
just like that. But where is it? I saw something where it has a C there.
I said
The
n
first one that you
combination r
you.
same as what?
Uh-huh.
N combination. It's the same thing. This is just a
Oh,
notation.
it's the same
Yes.
thing. Okay,
Yes.
okay, I get it. I get it. Okay, okay.
Right. So this is the same thing. All right.
Okay. No, I get you because I was just seeing you doing that, so I was wondering what you're trying to do.
So I also made
Right.
mention, all right, to now say the application of combination comes as follows. For instance, a question will come. Most of the questions that I make up, I make up from experience. I've seen this question in the exam. So how do we know it's a combination? Say, a question will come to say, a class has 5 accountants and 8 economists. In how many ways can we have what? In how many ways can we have? Can we have 2 accountants and 3 economists? So this is a combination. So I taught you how to use a combination using the formula. So part A, we know that they are looking for 2 accountants and 3 economists. So out of the 5, we're looking for how many accountants? 2. And means what? In probability multiplication. Out of the 8 economists, we need how many? 3 economists. So now you can compute even using a calculator. What is 5 combination 2? Is 10. Times what is 8 combination 3? Check, is it 28 or 56? Compute.
56.
56. So there are 560 ways of having a committee having 2 accountants and 3 economists. Now again, the examiner can say, in how many ways can we have at least 2 from each faculty? At least 2 from each, but having a total of 5. Total of 5. So we can have 2 we can have 2 accountants, then the remainder, and 3 economists, or we can have what? 3 accountants, and how many economists? 2 economists. Is it possible to have one accountant and 4 economists? No, because the minimum
No.
each faculty should be what? At least 2. So these are the 2 only possible entities. So here we're going to say 5 combination 2, and means multiplying. 8 combination 3, or means what? We are adding statistics. Then we start now 5 combination what? 3 times 8 combination what? 2. So here we would expand this as follows. So 5 combination 2, we already calculated this part was 10 times what? 56. Plus, what is 5 combination 3? 5 combination 3 is what? Still 10? Yes. And 8 combination 2 is what? 28. So we're going to have 560 plus weight. When we add these two, we're going to get 800 and what? 840. These are ways in which we're going to make a committee that will have at least 2 from each faculty, having a total of 5. Anyway, that I didn't teach as much. I just wanted to make mention on the counting numbers. Now, lastly, suppose you're given a question. I think I sent this question on the group yesterday. Suppose you are told that you want to make a number plate with 3 letters. Okay, it's a letter, and this a letter, and this a letter. And the numbers should be followed by how many numbers? Maybe 4 numbers. And you are given prescription because you are working at RATA. They're telling you that in how many ways can you make a number plate without restrictions? So how many letters do we have in the alphabet? 26. 26. 26. How many numbers do we have? In total, there's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 numbers that we have, right? 10, 10, 10, 10. So the number of possible ways in which you can make a number plate with 3 letters and 4 numbers is simply multiplying what? 26 times 26 times 26 times 10 times 10 times 10 times 10. Okay. Now, if the examiner now wants to make it a little bit fancy, says the prescription that the first number should be a non-zero number. So meaning this one will be moderated. Instead of putting 10, 0 doesn't qualify there. So you multiply 26 times 26 times 26 times 9 times 10 times 10 times 10. You understand, right? Right? So this is how such questions will come. Let me take you to an example question which came in that similar manner. So we are told that the manufacturer wants to what? To make different make different colors of different cars. So manufacturer wants to tell me how many different cars can be produced if all options are considered, and the choices are given below. There's a body type, there are 4 options. Engine type, there are 5. Interior color, there are 9. Exterior color, there are 9. Interior color, 5. Tire type, 4. And accessories are 10. So in how many ways can the car be made different? We just multiply them as they are. 4 times 5 times 9 times 5 times 9 times 11. The final answer is what? Final answer is the total number of ways. Is that clear? How to get that so far?
Yes.
All right. Now, I'm going to take you to probability using the contingency table. Now, usually I love to work with simplified versions. That table, no matter what table you be given, once you understand this simplified version, you are good to go. I like A, B, X, and Y. For instance, we're given numbers of 2, 4, 6, and 8. So the first thing is you need to do what? To total up. The total here is what? 6. The total here is 14. The total here is what? 8. The total here is what? 12. So for the totals, you need to find the grand total. The grand total here is 20. So the way I'm going to explain this is the way I want us to apply that exam type question. So the probability of picking an A is simply the total number of A's over the sample space. Our sample space is the total of total. This is our sample space. So the total of A is what? 6. Out of the sample space, 20. So we're going to get 0.3. Preferably leave it in a decimal point. What's the probability of picking a B? You go where there's B, you get the total there. What is the total? Is 8 over what? 20. 0.4. Let's go to X. What's the total for X? You go where there's X. The total here is what? 14. Out of what? 20. 0.7. Then for Y, the same application. We're going to do what? On the Y here, the 12 out of the grand total of the sample space, which is 20, we get 0. What? 0.6. Now, if they're going to ask us to find the intersection of A intersection B, you identify where the A meets by using a class. A and B, they meet at a 2. 2 out of what? Out of 20. We get 0.1. However, if you're asked to find A union B, who remembers the formula for A union B? Unite is to add probability of A plus what? Probability of B minus what?
The probability of A intersection B.
Good.
Yeah.
So what is the probability of A? 0.3. Probability of B? 0.4. And the intersection we just found as 0.1. So what do we get? 0.6. Now, help me find X intersection Y and X union Y. Quickly, the ladies and the gents, choose each one of what you're able to. The ladies can do the easier one, X intersection Y.
We want to do the hard one.
And the other one,
Okay.
guys, you've been given the easier one. It seems you're not talking a lot, so the ladies are tired of easy ones.
But which one is the easier one there?
That's
Because they are all the same.
A
Which one is the
intersection-
easier one, man?
A intersection B.
No, as in, are we oh,
X intersection Y, sorry. The one they've given you, they are too lazy to do this one. They're saying this one can answer even with our eyes closed. So try this one, X intersection Y. How do you get it? Quickly, I can't hear any. You see what I wanted the ladies to do? The guys are very quiet. They can't manage that one. Yes, ladies, pick up both. Ronnie,
8 over 20.
where they meet 8, then the total.
Over
sorry, so my mic was mute. I was talking 8 over 20. We'll do the other one.
No, they're copying from the ladies. She's already said this answer, I'm sure.
Ah, come on.
Okay.
You're in charge.
Okay, let's try now. X union Y, the ladies. How do we do this one?
Probability X plus probability Y minus intersection X and Y.
Okay, so what's the probability of X?
Yeah.
0.7.
2.7. Y?
0.6.
0.6
Intersection.
minus 0.4.
Final answer. 0.9. All right.
Oh, yeah.
Here. Now, if you're being asked to find the probability of A given B, using Bayes' theorem, what is A given B? You bring the B down there, and on top, you're going to put what? A intersection B. That is what according to Bayes' theorem. So what is A intersection B? 0.1. What is probability of B? 0.4. So when you divide 0.1 divided by 0.4, you get 0.25. So now, since I've given you this prototype, lead me through how to find B given A. How do we expand this using Bayes' theorem? B given A. Which guy goes down?
B, A, sorry,
Probability A.
yeah, A.
Then on top what we have?
B intersection A.
intersection B.
Intersection A or intersection B, it's the same thing. So our A intersection B was what? 0.1. Probability of A was 0.3. So 0.1 divided by 0.3, what do we get? 0.33. Right. So I'm just redrawing this. Any questions so far?
When do you use the Bayes theorem? Or how do you know that you need to use the Bayes theorem of this particular, or for your particular question?
So there's a question for everyone there. Who wants to answer? How do we know it's Bayes theorem? This, just know that as long as there's some intersection somewhere, it's Bayes theorem. This is Bayes theorem. It's conditional probability. As long as you see a table like this and probability being asked, just follow what has been done. So I'm going to teach you a shortcut of finding A given B if you don't want to use the formula for Bayes theorem. Just go where they meet A and B, they meet where? At 2. But the total for B is 8. So 2 over 8 is 1 over 4, which is 0.25. So now that I've shown you that, what is B given A using the shortcut? What is B given A? They're meeting at what? At 2. But the total for what? For A, which is 6. So this is 1 over 3, which is 0.33. Are we getting the same answers? Yes, that's what we got there. Now, what I haven't solved is X given Y and Y given X. So ladies, since you have the tougher ones, choose before the guys choose. X given Y and Y given X. Harry. What is X given Y? What do we do?
X given Y is 8 over 12.
They meet at 8, but the total of Y is what? 12.
The total of Y is 12.
Then this one, Y given X, 8.
So it's still 8 over 14.
14, correct. Now we are ready to look at the exam question. So don't embarrass me. We have this. What's the first thing you need to do when you're given a contingency table?
We have to add.
Total up, yes. What's the total here? 0.2. Continue. Total here. Quickly.
0.59.
0.59. Total here.
0.21.
0.21. And total down here. 0.28. Total here. 0.72. And the grand total is 1.00. Now, I need you to participate each one. What's the probability that a randomly chosen home will subscribe? So we're looking at this will subscribe, will not subscribe. So we can say this is S, and maybe this is S complement. This is low, middle, and high. So what are they asking for? Probability that they will subscribe, probability of S. Wants to try? What's the probability of S? Probability of S is the total for S over the grand total. 0.28 over what? 1.00 or 1. What we get? 0.28. Is that clear? All right, what's the probability that our income and willingness to subscribe? What income is that? Low income. So here it was not specific. So let's assume what's the probability that they are low income and willingness to subscribe? The word end means what?
Multiplication,
Multiplication,
intersection,
intersection, specifically good. So what's the probability that they are low income and willingness to subscribe? So probability what? Low intersection S. Yeah. What is low intersection S? What are we going to get?
0.04 over 1
0.04, correct?
over 1.
Over 1, the grand total, which is 0.04. Then here, given a high income family. So whenever you hear given, meaning that statement will follow under the slash. So given low, so meaning you're going to say probability given low. Well, this is given high, in fact, given high. So given H, what is the probability that they will subscribe? So S given H. So I've given you the notation. So what do you do? S given H. The gents, they're too quiet. S given H, where do they meet? S and H?
So you go where S meets H over the total of H.
Where total of H, correct. So where do they meet? S and H? 0 point?
0.11,
Then the total for H is what?
0.21.
0.21, excellent. So what do you get when you divide 0.11 over 0.21? 0.538. So can you give me the notation, given that household to subscribe, what's the probability? High income. So what is the notation here? Given household to subscribe, what's the probability of high income? What is the notation?
Probability of H given S. So S is given.
So what comes on top and down?
H
Right.
comes on top and then S down.
Continue. What next? Yeah, I can hear. Yeah, I can. You can call me in 10 minutes, in 15 minutes, I'm in class. Yeah.
So 0.11,
So when they meet S and H, it's still 0.11, right? But the total for
yes, over 0.28.
the total for S, which is 0.28. Right. So when you evaluate that, what are you going to get? 0.3929. So this is how we get our, how many marks is that? 8 marks. So this contingency table is coming. You probably need to factor in the concepts that we've talked about. Any questions? Anyone behind? Anyone lost on this question? Are we clear? Okay, lastly, last 10 minutes, let me try to explain the concept of binomial. I means what? True. So you perhaps need to understand the 4 properties of binomial distribution. So binomial has about 4 properties. What are they? Number 1, events occur independently. Number 2, events have equal chance. Number 3, n trials are stated. The n is given. And finally, we have the success and the failure, P and the Q. Given success and failure. There are 2 possible, by means 2, the 2 possible outcomes that are given. All right? So under binomial, the formula for binomial is given by what? By the following. N combination x, and here we have our P, and here we have our Q. The x will come here on the P, and the difference between x and n will be here. Then the mean under binomial is given by NP, and the variance is given by NPQ, and the standard deviation is given by the square root of NPQ. Please don't mix the formulas for statistics and the formulas for binomial. Don't mix them up. So quickly, suppose you're given our values of n to be 4. And you're given P maybe to be 45% or 0.45. So number 1, how do you find the Q? What is your Q? Q is the difference from 1, P from 1. So to find our Q is 1 minus 0.45, which in this case is what? 0.55. So the mean, how do you find the mean? Anyone? The lady? Ladies are the ones answering.
Over
N times P.
NP.
0.5.
Our N is what? 4.
4.
P is what? 0.what?
0.45.
45. So what becomes our mean? Yes, Mr. Gaivas, are you there? Calculate.
Sorry, Collins, I'm with a guest. I'm attending to a client.
All right. No problem.
I'll get back to you soon. Thanks.
Thelma, all right, okay. Thelma, what does that mean?
1.8.
1.8. How do you find the variance?
That's N times P times Q.
NPQ. So our Q is what? So when we apply all that, what are we getting? 0.99. Okay. Standard deviation, how do you find standard deviation? Square root of the variance. So in square root
Square root of the variance.
999, what do we get? 0.994. Almost the same. All right, on this one, we are good. Now, suppose you're told to find the probability that our x is equal to 0 or none. Whenever you have none, you're talking about x is equal to 0. So our n is what? 4. Which is 0. Now, I taught you the Pascal's triangle, sorry, to divert briefly, because this I love, especially when you're understanding how to, those of you who don't have calculators. So you start with 3 ones there. 1 plus 1 is 2. You add a 1 plus 1, you have a 3. 1 plus 2 is a 3. 2 plus 1 is 3. You close with the ones. And here 3 plus 1 is what? 4. You just add sum up and put a sum down there. 3, 1, 4. Then you close. 1, 4, 5. 4, 6, 10. 10. Then you have a 5 there. You close. Here, what do we have? 6. Here, what do we have? 15. Here, what do we have? 20. Here, what do we have? 15. Here what do we have? 5 plus 1, 6. Then you close the ones. Here what do we have? 7. This plus that, 21. This plus that, 35. This plus that, 35. This plus that, 21. 6 plus 1. You close, then go on and on and on. I love ending at 7. What this simply means is that 7 combination 0 is 1. This is 7 combination 1 is what? 7. This is 7 combination what? 3, get 21. 7 combination what? 4, get 35. 7 combination what? 5, it's also 35. 7 combination 6 is what? 21. 7 combination 7 is what? Or 7 combination. This is combination 0, 1, 2. Okay. This is 2. This is 3. This is 4. This is 5. This is 6. And 7 combination what? 7. What this means that n number combination 0 is 1. Combination 1 is itself. N number combination itself is itself. Combination second last number is itself. Combination itself is 1. So let's go on 6. Just using the table here, can somebody tell me what is 6 combination 3? 6 combination 3? You go by the
20.
1, 2, 3.
20.
6 combination 0. And number combination 0 is what? 1.
1.
So don't abuse the calculator sometimes. 6 combination 6 is 1. 6 combination 1 is 6. And number combination 1 is that number. 6 combination 5, the second last number is itself 6. So marama kulama 1. 7, the second last number is 7. So just these two you can memorize. So I can say 100 combination 0 is what? What is 100 combination 1? What is 100 combination 100? What is 100 combination 99? These ones you can't use a calculator. Can somebody help? 100 combination 0?
1.
100 combination 1?
100.
100 combination 100?
1.
And 100 combination 99? 100. So you could see
100.
this format. Apart from here, what is 4 combination 2? What that part is 4.
Is 6.
4 combination 2, so 1, 2,
6.
Found one. Are we together?
Okay. Yes.
So we
Yes.
go back here. Now, that's where the background of whatever I'm talking about is. So we put our 0. What? Our P is 0.45, our Q is 0.55. So I want us to now calculate the 4 combination 0. 0 yara kamura. The difference 4 minus 0 is 4. Yara. What is 4 combination 0? 1.
Is 1.
0.4 to the power 0 is 1. 0.55 to the power 4. You check on the calculator. And papata to the power looks like this. For other parts, the power looks like this. So you need to study your calculator very well. So 0.55 to the power 4 is 0.0915. So our final answer is 0.0915. So let's go to probability of x is equal to 1. So 4 and 1 looks like that. Then here we put our P is 45%, meaning our Q is what? 55%. So where does the 1 go? 1 yara
On top of P.
P. Inga on the 55 is the difference. 4 minus 1 is what?
4 minus 1. 3.
The total guys must add up there. They must tally. 4 plus 0 is 4. 3 plus 1 is the must tally. What is 4 combination 1 without using a calculator?
4.
4, good. What is 0.45 to the power 1? 0.45.
0.45.
What you can use a calculator is 0.55 to the power 3. What do we get?
0.166.
1664. We have leave them in 4 decimal places. So multiply all the 3, what we get? 2995. So this is 2995. Please don't get any number 1 point something. Probability should always be 0 point something. You can't get anything above. All right. If x is equal to 2, the ladies, this one is easy. You say the guys will be going for the easier ones. The ladies for something tough. So what do we do here? For combination 2, what the guys?
0.45 to the power 2
0.45 to the power 2
times 0.55 to the power 2.
0.55 to the power 2. Okay, that's correct. So what do we have? So what is 4 combination 2? 6. 0.45 squared is 2025. And 0.55 squared is 3025. You apply all these, what we get? $36.75. All right, Nombich Sungu. Remember, at this point, if you are told to find the probability of at most 2, probability of at most 2 means what? 2 and below. So if you're asked to find the probability at most 2, we're looking at what? Probability of x less or equal to what? 2. So we're looking at the probability of 0, probability of 1, probability of what? 2. You add and sum them up. That's what it means at most 2. I'm not going to give you the final figure. I just want you to understand the concept. How about at least 2? What does at least 2 mean? It means x is greater or equal to 2. So meaning probability should start at 2, going to 3, upwards to our n, which is 4. Okay, so you can choose to find the probability of 2, 3, and 4. You add them up, or the easier way out is 1 minus the missing numbers, the unlisted numbers, the numbers before the 2. So it's a probability of what? 0 plus probability of 1.
Probability of 1.
Okay, so probability of 0 and probability of 1, we already calculated them. So you add them here, and the sum total you subtract from what? From 1. So that's what you do. So your homework basically is question number what? Number 3. This one is basically on binomial. We're trying to do it in a way. And then in there for 5% of the stocks, the stock exchange, on the lower stock exchange, if I randomly selected 4 stocks, what's the probability that 2 or fewer will have value? So it's probability of at most 2. What's the probability that exactly 3 of them will increase in value? So probability x is equal to 3. What's the probability at least 3 of them will increase in value? It's 3 and 4. So this is carrying about how many marks? 9 marks. So handle that and send it to my inbox. I rest my case. Thank you so much and have a great day. Those are writing today, all the best.